Hi, this is Algebra 1. This is lesson 61. We're going to talk about subsets. And we're starting on page 247. If all the members of one set are also members of a second set, the first set is said to be a subset of the second set. So if the set of B has members 1 and 2, and set A has members 1, 2, and 3, then B is a subset of A because all of its numbers are in A, and then A has other ones. Okay? So we would write that as B is a subset of A. Remember before we were using this symbol, this is an element of. So this guy without the fork in the middle is a subset of. So this means is a subset of. And if we put a line through it, then this is not a subset of. So in this example, A is not a subset of B because A has a 3 and B does not. So A is not a subset of B, but B is a subset of A. If we add another set, so C contains the members of 3, 2, and 1, then C is a subset of A, and A is also a subset of C because they both have the same numbers. They're equal sets. So A is a subset of C, and C is a subset of A. A set that has no numbers is called an empty set, and you can write that as either just braces with nothing in the middle, or this means empty set or null set. Null sets or empty sets are considered subsets of every set. So an empty set would be a subset of A, or a null set is a subset of B, or whatever. So these mean empty set. Okay, here's an example. Given the sets D equals 0, 1, and 2, E contains the member 1, 2, 3, and so on, and G contains 1, 3, and 5, tell which of the assertions are true, which are false, and why. So we'll start with A. It says E is a subset of G. So let's look at E. E contains 1, 2, 3, dot, 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 dot. And G contains 1, 3, and 5. So E cannot be a subset of G because all of the numbers in E are not contained in G. So this would be false. And you would write, false, all the members of set E are not members of set G. That's not so hard. Okay, is G a subset of E? So G contains 1, 3, and 5, and E contains 1, 2, 3, and it's going to continue on infinitely in that pattern. So does it contain 1, 3, and 5? Yes, it does. So this is true because set E does contain all the numbers from set G. Is D a subset of E? Well, D contains 0, 1, and 2, and E contains 1, 2, 3, on into infinity, but it does not include 0. So D is not a subset of E because D contains 0 and E does not contain 0. Okay, now we're going to talk about subsets of real numbers. The set of real numbers is an infinite set. An infinite set has an infinite number of subsets. Another way to write real numbers is this fancy R with 2 lines. Sometimes you're going to see that. So the set of real numbers is an infinite set. Here are some of its subsets. We have natural numbers, which are our positive counting numbers starting with 1. So 1, 2, 3, and so on. Right? And then we have whole numbers. Whole numbers are the natural numbers plus 0. So we start with 0 and then we do the positive counting numbers. Those are our whole numbers. Integers, which you can also write with this fancy Z with 2 diagonal lines, are all of the whole numbers and their negatives. So we have -3, -2, -1, 0, 1, 2, 3, ... and there are actually ... dots here. Okay? It goes infinitely in both directions. Okay, those we've covered before. Now we're going to talk about rational numbers. The root word of rational is ratio. And a rational number can be written as a ratio or fraction of integers, where the denominator is not a 0. So these numbers are all rational numbers. 1/4, -3/17, -10, because we can write this as -10/1, or -20/2, or -30/3. 0.013. This is 13/1000, right? We can do the square root of 1, because that's really just 1. Or the square root of 4, because that's really 2, right? So these are all rational numbers. Irrational numbers cannot be written as fractions of integers. So these are going to be numbers such as the square root of 2. The square root of 2 turns out to be 1.414121356. This decimal continues on infinitely, and it does not repeat. The same is true of the square root of 3, which is 1.7320508808 ... Or pi. Pi is probably the most famous irrational number. It is 3.141592654 ... My husband can tell you many more numbers. They go on forever, and the decimals do not repeat. Because they go on forever, we can't make a ratio out of them. We can't say it's 1 in 41/100ths, or 1 in 4142 over, that would be 10,000ths. We can't do that because there are more numbers. So we can never make an accurate ratio out of these numbers, and therefore we call them irrational. Okay, here are some useful facts about irrational numbers. Number 1, the product of an irrational number and a non-zero rational number is an irrational number. If you multiply it times 0, you just get 0. But if you multiply an irrational number by a rational number, you end up with something like this. 2.82428727125 ... And once again, it's a infinitely long decimal. So it's now an irrational number. The sum of an irrational number and a rational number is also always an irrational number. If you add the square root of 2 to 2, you're just going to get 3.414213562 ... Okay, so there's this nice chart on page 249. It shows that real numbers can be divided into two big subsets, the rational numbers and the irrational numbers. In the rational numbers, we have integers and whole numbers and natural numbers. Those are all rational numbers. And then on the other side, we have irrational numbers. The two subsets of rational numbers and irrational numbers are mutually exclusive. There is no number that is in both of these sets. Okay? Okay, so here's an example. Considering these sets, and these are the 6 sets we're going to be working with, the natural numbers, the whole numbers, the integers, the rational numbers, the irrational numbers, and the real numbers. 1/2 is an element of what subsets of real numbers? So 1/2 is not a natural number. It's not one of our counting numbers. It's not a whole number. It's not an integer. It is a rational number. It's not an irrational number, and it is a real number. So the answer to this would be rational and reals. Instead of writing out rational number and real number, you can write rationals and reals. So 1/2 is a rational number and it's a real number. 5 is an element of what subsets of the real numbers? Well, it is a natural number. It is a whole number. It is an integer. It is a rational number. It is not an irrational number. It is a real number. So it is in part of 5 subsets. Okay, now we have 3 times the square root of 2. And we remember that the square root of 2 is irrational, and that any number, when you have a rational number multiplied times an irrational number, the product is always going to be irrational. So we're going to skip all these guys because these are all rational numbers. We're going to go straight to irrational. And real. So it's an irrational number and it's a real number. Next year you will get to numbers that are not considered real numbers. We call them imaginary numbers, but you don't need to worry about that right now. Okay, here's another example. Tell why the following statements are true or false and explain why. Okay, the first one is the real numbers are a subset of integers. And that's obviously false. Real numbers, all of our real numbers are not contained in the integers. So this is false. Because all real numbers are not integers. All real numbers are not integers. The set of irrationals is a subset of reals. And that is true. All irrational numbers are also real numbers. True. All irrational numbers. We're just going to say all irrationals are also reals. The set of whole numbers is a subset of natural numbers. And that's not true because the whole numbers contain 0 and the natural numbers do not. So this is false. Actually, the opposite would be true, right? All wholes are not in naturals. Irrationals are a subset of rationals. And that's false. Remember that irrationals and rationals are mutually exclusive, which means there are no numbers that are in both. So irrationals and rationals are mutually exclusive. Integers are a subset of reals, and that's true. All integers are reals. All integers are real numbers. Okay? That's it for this lesson. Try your practice problems and let me know if you have any questions.